Determine the tension between boxes B and C if the coefficient of friction is 0.25. So in this type of problem, when there's multiple boxes, you want to try your best to make it into one system. So don't start out by drawing the free body diagram of each object, but try to look at it from, just imagine it's one thing, like A, B, C is going to combine into one box. So first what you want to do is write Fnet equals MA, and we're going to look at the whole system first. And in this case, for Fnet, you want to look at all the forces that are being applied to this system that is not the tension force, because that's an internal force and you don't need that when you're calculating for the whole system. So first of all, you don't really know whether this system is moving or not, but usually in these types of problems, it's going to be moving. So in this case, well, it's obviously not going to move in this direction because there's no force going there, and it might move in this direction since there's a gravity that's pulling on A. Okay, so let's start by replacing Fnet here with all the forces that are acting on it that's not tension. So first there's the gravitational force on A, which is pulling it down. So let's assume that it's moving downwards. And then there's going to be, since the question is giving you the coefficient of friction, that means there is friction. So friction opposes the direction of motion. So for box A, friction is going to go this way. So use lowercase f for friction, and here's just Fg. And we're not going to look at these tension forces because if you're looking at the forces that are acting on the system, the whole entire system, not just one of the boxes, you don't have to worry about tension. So let's move on to box B. Well, we don't care about the tension, but there is going to be friction since we're assuming that it moves this way, and the friction is going to be opposite that direction, this way. And then for C, it's the same thing. We're assuming it's going this way, so the friction would just be going this way. So when you're writing this formula, first you want to write it just adding everything up, and then you can use negative for the different directions. So we're going to add up all the forces. So we've already got the gravity force of A, and now we need the friction force of A, and then the friction force of B, and then finally the friction force of C. And that's going to equal to MA. Now we can use some formulas to figure out what the Fnet actually is. So first of all, let's do FGA. So I'm going to redraw box A over here. And yeah, so there's a component of gravity that's pulling it down. And to calculate this force, we're going to draw a triangle in here. And this line over here is the same as this line here. So they're both the same as FG. And we know that the formula for the force of gravity is mg. So this line here, it's mg. But we don't want this vertical line. We want the component that is making it go down, which is this line. And to find that, we can use the angle here, which is going to be the same as the angle here. So this is also 60 degrees. And we can use some trig stuff to find out what FG is. So in this case, FG is opposite to the angle, so we're going to have to use sine. So sine theta equals FG over the hypotenuse, which in this case, you can see that this is a right triangle. So the hypotenuse in this triangle here is mg. And we want FG, so to isolate for FG, we can multiply mg by sine theta. So that's the formula that you use for the force of gravity when an object is at an incline. So let's just make some space. There we go. So yeah, what did we say? We said that FG is the same as mg sine theta, which in this case is 60 degrees. And now we have to worry about the positives and the negatives. So if it's usually in these types of problems, the direction of motion is positive. So we're assuming that it's going this way. So any force that is acting in this direction is positive, and if it's acting in the opposite direction, it's going to be negative. Okay, so Fg, well, that's going in the direction of motion, so it's positive. And Fa, that's in the opposite direction of motion, so it's going to be negative. And we know that the equation for friction is mu times the normal force. And the normal force, in this case, is going to be a bit different. It's not going to be mg. Let's draw the triangle thing again. So the normal force is perpendicular to the surface that it's on. So right now it's on this surface, and perpendicular is this line over here. Right here, it's perpendicular to the surface, and that's equal to the normal force. So to get this, we have to use trig identities again. And in this case, we need to use cos since it's adjacent to this angle. So cos theta equals Fn over hypotenuse, which again is mg. And then to isolate for the normal force, multiply mg by cos theta. There, that's the equation for the normal force when an object is on an incline. Okay, so now we can add it back here. The force of friction is mu mg cos theta. So let's put this right here. And pick some space again. Hopefully this goes better than last time. Oh, very nice. Okay. So now that we've got the friction force on box A, let's look at the friction force on box B. Well, it's obviously opposing the direction of motion since it's moving this way, which means we're going to add a negative sign. And remember how the force of friction, the equation is U normal force? In this case, B is not on an incline. So we can just use normal force as we've always done it, which is mg. This is Fg, and the force pushing on the box is the same but in the opposite direction. It's perpendicular to the surface. And the formula for Fg is mg. So we can just replace this with mg. And then we've got one more force to worry about, which is a force of friction on C. Again, the force of friction on C is moving in the opposite direction of motion, so it's going to be negative. And the force of friction is mu mg, since it's basically the same as B. And all of this is equal to ma. So remember, what we're trying to look for right now is the acceleration, because once you find the acceleration, you can start to look at the actual tension force in one specific block. So let's plug in some values. Let's start with this. M for A is 25. G is always 9.8. Minus, in the question, it gives you that the mu is 0.25. The M is 20. Hold on. Yes. So we're doing the friction for blocks A. So again, we're going to use the mass for blocks A, which is 25. G is 9.8. Cos 60 degrees. Minus mu is 0.25. And in this case, we're looking at the friction of block B. So we're going to have to use a mass of block B, which is 10. G is 9.8. Mu is 0.25. And then we're doing the force of friction for block C, and the mass of block C is 15. G again is 9.8. We're almost there. And the M over here, remember how I said that we're gonna look at the whole system and pretend it's one thing. Well, that just basically means that the mass is going to be mass A plus mass B plus mass C. And that turns out to be 50. And now, all we gotta do is plug this whole thing on the left into a calculator. Okay, so I got approximately 120.3 on the left. And to isolate for A, we can divide both sides by 50. So 123 divided by 50 is about 2.4 meters per second squared. And that's the acceleration of the whole system, which means block A, block B, block C are all going to accelerate at 2.4 meters per second squared in this direction. Okay, so now that we got the acceleration, we can start by finding the F net for a single box. And in this case, they want us to find the tension between B and C, which means we can either look at box C or box B. And you can do either one and it's supposed to work, but usually we want to pick the one with the least amount of forces acting on it because it's easier, or just whichever one looks easier. So right now, box C, the only forces acting on it is tension and friction, versus box B, there's tension on the right, tension on the left, and friction. So box C is going to be easier for us to solve. So let's try to find F net for box C. So this is going to be the F net for box C, which is also equal to MA. The F net on the left is going to equal to the tension force plus the force of friction, because these are the two forces that are acting on box C. And again, now we can rewrite this to make sure the signs are correct. So the tension force is going this way because it's pulling box C to the left, which is a direction of motion. It's going to be positive. But for the friction force, it's opposite that. So that's why friction is negative. So negative friction equals MA. And we're trying to find the tension. So to find the tension, just add friction to both sides. So you get MA plus F. And to plug in the values, since we're only doing it for box C, we can use the mass of box C, which is 15. And since we already got the acceleration, which is 2.4, and the friction, well, let's rewrite something. Friction, if it's on a flat surface, is mu mg, since the normal force is equivalent to mg. And mu in this case is 0.25. M again, 15. And g is 9.8. So let's see what we get. .75, and to round it to the correct number of sig figs, well, how many sig figs does 0.25 have? Well, 0 is not counted, but everything after the decimal place is, and there's 1, 2 digits after the decimal place, so we're going to keep 2 sig figs. So the answer is going to be 73 newtons, and that's the tension force between boxes B and C. Determine the tension in the rope joining A and B if the coefficient of friction is 0.23 for all surfaces and the masses are as follows. So as you can see, this is kind of similar to the other problem, except now they are both on angles, which means both of them have a force of gravity that's being acted on it. So usually what you want to do is find the acceleration and then find some type of force that is acting on one of the boxes. But right now, we don't know which direction is accelerating. It could be accelerating this way, or it could be accelerating this way. We don't really know. So to figure out, what we want to do is find the force of gravity that is acting on each box. So the force of gravity on A is going to be this way, and the force of gravity on B is this way. And whichever one is greater, that's going to be the direction in which it is accelerating. So let's begin by finding the force of gravity for box A. So we know that the force of gravity, well, in this case, it's on an angle, which means we're going to have to use some trigonometry. And the force of gravity is equivalent to this line. And this angle here is 30 degrees. So we can use sine since it's opposite of the angle. And you can do this by just doing sine theta equals the FG divided by the hypotenuse, which is mg. But I'm just gonna do a fast way, which is you take mg and then you multiply it by sine theta, which in this case is 30 degrees. But if you want to know how I got this, you can just use sine 30 and find what that's equal to, and then solve for the force of gravity. So next thing you want to do is to plug in some numbers. So the mass of A is 25. Force of gravity is always 9.8. And sine 30, that's actually a special trig angle, and it's always going to be 0.5. So let's see what that gives us. So I got 122.5 newtons. So this is the force of gravity on A. Now we want to find the force of gravity on B, so we can compare and see which one's larger. Again, since it's on an angle, it doesn't matter which way it is. You can always use just mg and then sine theta, which in this case is 60 degrees. The mass of block B is 50. G is always 9.8. And sine 60, well, that's a special angle as well, but I forgot what it was, so we can just use that in our calculator. And that gives us 424.35 newtons. Okay, so which force is larger? Well, 122.5 versus 424.35. The 424.35 is much larger. And this means that everything is going to accelerate in this direction. Okay, so now we need to find the acceleration. And to do that, we want to use F net equals ma and apply it to the whole system. So we can just start by writing F net equals ma. And remember, for F net, when we're doing the whole system, we're going to add up all the forces that are acting on each object, except the internal force, which in this case is tension. So let's start with block A. Well, we have Fg. We also have the force of friction, and we know this because the question is telling you the coefficient of friction. So that means there is friction. On block A, we're going to ignore the tension force and add the force of gravity on block B. And block B also has a force of friction, which is all equal to ma. And now we can start putting some positives and negatives on things. So we know that the direction of motion is this way. That means anything that is going in that direction is going to be positive, and anything that's going in the opposite direction is negative. So if we take a look at the force of gravity on A, that is going in the opposite direction. It's not going in this direction, so it's going to be negative. And we already got the number for it, which is 122.5. And friction opposes the direction of motion. As we know it's going this way, friction has to be going this way. So that's going to be negative as well. And to calculate the force of friction, you need to use mu times normal force. In this case, the normal force is this force over here. Since it's perpendicular to the surface, and divide that, you can just do cos 30, which is going to be equal to the normal force divided by the hypotenuse. And I'm just going to use a shortcut, which is mg times cos of the angle, which is 30 degrees. And again, if you don't know how I got that, I just did cos 30 degrees, and you can find what that's equal to, and then isolate it for Fn over here, this side. Okay, so the next force is a force of gravity on object B, and that is going in the direction of motion, so we don't have to minus it, we can do plus. And we know it's 424.35. And the friction of block B is opposing the direction of motion, it's going in this direction, so it's going to be negative. And again, we can use the exact same formula, mu times the normal force, which in this case is mg cos 60. And this is all equal to ma. And m is going to be the total mass of both objects, which is going to be 50 plus 25, which is 75. So now let's just plug in the actual values of forces of friction. Mu is 0.23, it gives it to you in the question. This is the force of friction of block A, so we're going to use the mass of block A, which is 25. G is 9.8. And then this is a force of friction on block B. Again, mu is 0.23. M of block B is 50. G is 9.8 times cos 60 equals 75A. So now we just kind of plug this whole thing on the left to a calculator. So I'm going to do that right now. So I got 192.456. I hope this is correct. I'm assuming that my calculator can do order of operations. Yeah, so I don't know if this is exactly correct. But it should be pretty close. So let's just divide both sides by 75. and we get 2.57 about meters per second squared. Okay, now that we have the acceleration, we can choose one of these blocks and find the net force on it, which is going to help us find the tension. In this case, I don't think it matters which block you use. You can either use A or block B because they're both equally difficult in finding. But let's just do block A. Again, we start with F net on block A equals M A, and this time we're actually going to use all the forces that is acting on block A. So that's going to be the force of gravity plus the force of friction, and then we're adding tension force. So we're assuming that the tension in block A and B is the same. So we already got 122.5, which is negative since it's opposite the direction of motion. And friction, which is mu, which is 0.23, times m, which is 25, g, and it's going to be cos, since we're finding normal force, it's this over here. So basically what I did, this is mu, this is mg, cos 30 degrees, and this is a normal force. And finally, plus t, since it is moving in the direction of motion. M is just going to be 25 since we're doing it for A. And we already know acceleration, which is 2.57. Now let's isolate for t. The t is going to be 25 times 2.57. Actually, you know what? Let's calculate this first. Negative 122.5 plus 0.23 times 25 times 9.8 times cos 30. That's negative 73.7. Adding tension, and let's calculate what's on the right side. $25 times 2.57. That's 64.25. Now all we gotta do is to add 73.7 to both sides. So it turns out my calculator actually did this wrong. It's actually supposed to be negative 122.5 minus 48.8, which is the force of friction, but my calculator did not do it correctly. So it was supposed to be negative 171.3. Okay, and then once you add it to both sides, you're gonna get 235.55. And now that I think of it, I don't think the acceleration is right either, because if I didn't do this correctly, this part, then I probably didn't do the acceleration correctly. So this is probably the wrong answer, but I think it's close enough. If you guys want to do it correctly, you can use your calculator and make sure to do it step by step and not just put the whole thing inside. I thought my calculator could do order of operations, but it actually can't. So yeah. Now, last thing we have to do is put the correct number of sig figs. And in the question, it's giving you 2 sig figs. And in the mass, it's giving you 1 sig fig. So it should be 200 newtons.